Okay, these are the notes for 1.4 in case you missed them out of class. We define acceleration and learn a little bit about it. Specifically, acceleration is how quickly velocity is changing. And so we can talk about it as delta v over delta t. One of the versions of the formulas that we're going to talk about is that kinematic, right? So that's one of the kinematics that we're going to carry around with us. It's really important that we have that. We'll talk about that in 1.5 as well, though. But acceleration is the slope of a velocity versus time graph. And if you think about that, if velocity is your y-axis and time is your x-axis, that's why we have delta v over delta t. That would be the slope. Acceleration is a vector. Okay, they do have direction. So if the velocity and acceleration are in the same direction, then you're going to see the object increase or increases speed. Whereas if the acceleration is the opposite direction of the velocity, then the object will have a decrease. The object decreases speed. The graph of position versus time, when we talk about position in relationship to time, when there's acceleration that's constant, this is going to be parabolic. The velocity versus time graph, however, will be a straight line or linear. And it should have a slope to it. So let's look at an example problem. If we drop an object near the Earth's surface, it's going to accelerate downward at a speed. So here's my object. Okay, there's an acceleration of negative 9.8 meters per second squared. We know that the initial velocity, which we use v0 to represent, is negative 1 meter per second. Now the reason we're going to use a negative is because it's also downward. So downward is our negative in this case. We could have changed all that to positive, but they'd asked us to use negative for downward. So, and the last thing we know is that time is 3 seconds. Okay, and we're asked what's the final velocity at the end of the 3 seconds, and then is it speeding up or slowing down? Well, using that equation, v equals v0 plus at. Keep in mind that this is our final velocity, which is what we're being asked to find. It would equal the initial velocity, negative 1, plus negative 9.8 times 3. We add all of that up, v comes out to negative 30.4 meters per second. Okay, now as a side note, looking at the numbers we're given, we're actually not given this many sig figs. Look at that, that's a single sig fig, that's a single sig fig. 9.8 is only 9.8 because that's a set value. Really this answer should be given with just one sig fig, meaning negative 30 meters per second. Now the question is it speeding up or slowing down? Down is technically negative, but if we look at the size of the number, it has gotten bigger in terms of being negative. So this is a speeding up. That's why when things fall towards the Earth, they don't slow down. They just continue to speed up until we hit what's called terminal velocity. Well, that's everything from 1.4. So good luck, and we'll see you in class.